All right, welcome back to my journey of extra credit. And we're going to be going over extra credit number 4 today. And it states draw any two different trisubcyclohexanes, any combinations of dashes and wedges, and show which is the more stable conformer. All right. Let me just pick one. Let's see. Okay, we'll do this one right here. Oh, God. Already I suck at drawing, and it bothers me that it's not connected, so I'm just gonna connect it real quick. All right, so that's our shape. We're going to go like this. Gonna be connecting, and this other one is going to go over here, and then we're gonna do a wedged one over here. All right, so the first thing we're gonna do is name it. In order to do that, we're gonna number first. Let's number this. Let's see which way we can number. I'm gonna say this way: 1, 2, 3, 4, 5, 6. Let's number the other way: 2, 2. I mean, just confuse myself. 2, 3, 4, 5, 6. See which one is the smaller one. You got 1, you got 2, and you got 4 right here. And then we got the other one, which is 1, 4. No, wait, 1, 4, and 6. So this one wins. This one's smaller, so let's not worry about this. All right. So we always want to look for the smaller ones, the smaller group, and this one is smaller because if you compare, it's 1, 1, 2, 4, 2 wins, so therefore this is the smallest one. All right, let's begin naming it. First, we got to figure out the parent, which is going to be cycle because it's in a cycle, and then hex because there's 6. Cycle hex, and we always add ane right here. Well, not always, but we add ane in this case because it's an alkene. All right, so let's begin with our number 1. So when we look at number 1, we're going to look at this one right here. So we always go based off of our naming rules, and our naming rules say that 1 is methyl. So for 1 carbon, it's going to equal methyl, so methyl. All right, and then in this case, we have over here our number 2. We have 1 carbon, 2 carbons. So we have 2 carbons here, and our chart says that 2 carbons is ethyl. All right, and then the next one says, well, we're on number 4 now, and since there's 1 carbon, it's going to be methyl again. All right, so now that we got this, let's combine these 2 right here because they're the same, just they're in different places. So we're gonna put 1, 4, and since there are 2 of them, dash dimethyl. And that's pretty much it for the naming. Now we just combine all of these. So let's do 1, 4 dash methyl dash 2 dash ethyl, and then we're going to add the parent, which is cyclohexane. And that's the name for this structure right here: 1, 4 dash dimethyl dash 2 dash ethyl cyclohexane. All right, now let's start drawing our chairs, and I'm going to attempt to draw a decent chair. So I like to draw mine like these, like this, I mean. I hope that satisfies because I'm not the best, but let's go ahead and try now. All right, so we're gonna start by numbering this this little chair. So I'm gonna number them from counterclockwise. So it's gonna go 1, 2, 3, gonna do is we're gonna look back over here. Oh, I forgot to mention one thing. This is really important. So we're gonna have to add some meaning to the dashes and the wedges. So in this case, our wedges are going to mean up and our dashes are going to be down. You can do it the other way around. Dashes can be up, wedges can be down, but I'm going to do it this way. And we're going to have to remember that axial equals up and down. Equatorial, I believe it equals left and right. I like to look at it as slanted because that's what they really are. All of the equatorials are slanted, but I'm pretty sure it's left and right if I'm not wrong. So let's begin now. All right, so number 1, it says it's going to be a dash. See, number 1 is a dash. We said that, not dash, a wedge, I mean, number 1 is a wedge. And we said that a wedge is equal to up. And so up is going to be like that. So that's going to be an equatorial. Equatorially up, like this. Hope that's good. And then after that, we're going to put the CH3 right there. And we're going to put a hydrogen right here because it's missing a bond right there. All right. And then the next thing we're going to be doing is number 2, which is right there. That's also a wedge. Wedge equals up. So up is an axial. We're going to do an axially up. This is going to be CH2CH3. And then don't forget our hydrogen. Hydrogen is going to look like this. It's going to be a equatorially down H. All right, let's move on to number 4. Number 4 is right there in the corner, and number 4 turns out to be a dash. All right, so our first dash, that means it's going to be down, and that means it's going to be equatorially down, like this. And that's going to be CH3, and our H is going to go up, H. So that's our first chair. Now we're going to flip it, chair flip. And we're going to basically flip this chair, so it's going to look opposite now, like this. Oh God, I'm not the best at drawing these. I'm trying. Okay, so all right, and in order to flip this, we also need to number it. But this time, since we were going counterclockwise, our numbers are going to go the same. I like to look at it this way. The numbers just rotate around. So our number 1 was right here. It's going to go up here now. It's going to be 1, 2, 3, 4, 5. And our new number 6 is right there. All right. Now that we have that, we're going to do the same process. We're going to look over here now. And we're going to see that our number 1 was equatorially up. And our new number 1 is going to be axially up. So it's going to be like this. Up. And then CH3. And we're going to put a number, not a number, a letter H for hydrogen, because as you can see over here, this is our number 1, and this was equatorially up. So now our new one is going to be axially up because it was up here, and the only way it can go up here is by being an axial. All right, so for number 2, we're going to do the same thing. It was axially up. Number 2 is now right here. So our axial up is going to look like this. Like that. almost parallel to that one right there. And it's going to look like this, CH2, CH3. And then we're going to bring the little H down over here. Our hydrogen. All right. So the next one is going to be number 4. Look at number 4 over here. It was equatorially down. So now it's going to be axially down, like so, like this. CH3. And our hydrogen is going to be equatorially up to the left. Yes, to the left. H. And those are both of our chairs. So now, in order to figure out which one is more stable, we go by this rule right here, which says equatorial. Did I spell that right? No, I didn't. Equatorial groups are favored, and big groups on equatorial position. All right. So since equatorial groups are favored and big groups on equatorial position are also favored over as many equatorial groups that there are, we're going to look that there is 1 equatorial over here, 2 equatorial groups. So we have 2. We have 1 equatorial group right here, which is this one, this big old group. And since the big groups on the equatorial position are favored, this is going to be the more stable. And that's our answer. Thank you.